Welcome to this presentation about performing a simple linear regression using PSPP. Presented by Deborah L. King, doctoral student at California Intercontinental University. Today, the agenda is as follows. We will examine how to use regression tests using PSPP, perform linear regression using PSPP, state the hypothesis test, rejection rule, and supporting details. We will also use PSPP to conduct the regression, examine the PSPP outcomes, main takeaways, and any questions. Through PSPP, the linear regression test is performed by following this path: analyze, regression, linear. The way we express the hypothesis for the regression is as follows. The null hypothesis, the regression coefficient, beta, is 0. Alternative hypothesis, the regression coefficient, beta, is non-zero. The dependent variable, which we will estimate, the independent variable, is the regressor. The rejection rule. We reject the null hypothesis if p-value is less than the alpha, assuming alpha is 0.05. Confirmation rule. 0 is not within 95% of the confidence interval. All the statistical talk boils down to one thing. Is beta significantly different than 0? If you recall the survey data collected during this class, the information from people regarding their income, savings, debt, and stocks holdings were examined. In these examples, we are going to see if, case number 1, we can predict debt by knowing the income. Case number 2, can we predict savings by knowing income? And finally, case number 3, can we predict stocks by knowing savings? We can figure this out by forming a linear regression to see if the beta is statistically significant and non-zero. The first regression hypothesis tests we know that the debt is the dependent variable and income is the independent variable. We also know that the hypothesis for regression. And then again, we also know the rejection rule. When the p is less than the alpha, we reject the null. And for most cases, the alpha is 0.05. Lastly, we are going to check the confirmation rule to see whether 0 is within 95% of the confidence interval. So what are we really asking? We're asking whether there is a statistical significance estimation of a particular debt using income. We state the null hypothesis and alternative regression. The outcomes. Let's take a look. A simple linear regression was conducted to determine whether observed aggression passivity scores could be predicted between debt and income. And our findings were as follows. No significant regression was found. The beta equaled negative 0.05, R squared equals 0.00, and p-value was equal to 0.535. The rejection rule, we fail to reject the null when we find that we do not have significant regression. P is greater than the alpha, where alpha is not equal to 0.05. The confirmation rule, 0 is within the 95% level. Case 1, debt and income. Income is predicted, and also the debt is predicted. Further, the 95% CI is negative 0.01, which is lower bound, and the 0.01 finding an upper bound. If you also notice, the p-value is above the 0.05. It is 0.535. So the results are as follows. Income is predicted and inconclusive, as we do not predict the debt. Further, the 95% confidence interval is stated with negative 0.01 and a positive 0.01, which does not contain a zero, hence leading to a non-support of the prediction. In the second regression hypothesis test, we know that savings is the dependent variable and income is the independent variable. We state the null and the alternative regression. A simple linear regression was conducted to determine whether observed aggression passivity scores could be predicted between savings and income. A significant regression emerged. Beta equals 0.91, R squared equals 0.82, and the p-value equals 0.00. We used the rejection rule. We rejected the null where p was less than alpha, where alpha equals 0.05. The confirmation rule, we have to ask ourselves, is 0 within 95% confidence interval? Case number 2, savings and income. Let's take a look. Income is predicted to increase as savings increase. Further, the 95% confidence interval, 0.09 is lower bound and 0.11 is upper bound, does not contain 0, hence lending support to the prediction. Also, if you will notice, the p-value is equal to 0.00, making the case significant regression between savings and income. We are on the third regression hypothesis test. This is the final test. And in this test, does the stock, which is a dependent variable, and savings is the independent variable. We're trying to find out which one matters. We state the null and alternative regression. A simple linear regression was conducted to determine whether observed aggression passivity scores could be predicted between stocks and savings. We find that there is no significant regression found. Beta equal a negative 0.28, R squared equals 0.08, and the p-value equals 0.00. The rejection rule, we reject the null when the p is less than alpha, where alpha is equal to 0.05. Confirmation rule is 0 within 95% of the confidence interval. Finally, case 3, stocks and savings. Savings is predicted to decrease as stocks increase. Further, the 95% confidence interval is equal to 0.07, which is lower bound, and a negative 0.25 upper bound. Does not contain 0, hence leaning support to the prediction. Notice also that the p is equal to 0.00, making the case significant regression between stocks and savings. What are the main takeaways? Well, we know that the PSPP can perform a linear regression. We can also perform a regression using analyze, regression, and linear. It is also important to obtain the coefficient, confidence, interval, and R. The dependent variable is trying to predict an outcome, while the independent variable can be called the regressor. Finally, simple linear regressions are not that difficult. This concludes conducting a simple regression analysis. And at this time, if you have any questions, please feel free to reach out to me. Again, my name is Deborah L. King. I am a doctoral student at California Intercontinental University. Have a great night. Bye-bye.